So, this is a cube of cheese. Okay? A cube. What's special about a cube? Every side is what shape? A square. Every side is square. So every one of these lengths here is equal to each other. Okay? Now, if it's a cube of cheese and you take a knife and slice it right down the middle, what shape will this make? Right here. A square. It'll still be a square. How can you slice that cube of cheese so you make a triangle? Where you'd see a triangle. Cut off a corner. Absolutely, Cooper. Cut off a corner. So you take this, you kind of slice this way, which would slice this way, which would slice this way, and you'd see a triangle. Okay? So this is called a cross section. We'll talk about cross sections here a little bit more in a bit. Okay. Faces, vertices, edges. Okay? What is a face on a polygon? What's a face? It's simply a what of the polygon? Side of the polygon. Okay? How many faces does this triangular prism have? It's a triangular prism because it has a triangle, and if you would slice it, it'd be all triangles all the way back. So it's a triangular prism, not a pyramid. How many faces does that thing have? 5. Because it has a side facing you in the front, a side in the back, and 3, 2 on the side and 1 on the bottom. 5 total. How many vertices does it have? Points. 1, 2, 3, 4, 5, 6 vertices. How many edges? Well, there's 3 in front, 3 in back, so that's 6, and then 3 connecting them, which makes 9. Okay, this is called a rectangular prism. This is a triangular prism. The second one is a rectangular prism. How many faces does it have? 6. How many vertices does it have? 8. 4 at the top, 4 at the bottom. How many edges does it have? 12. Okay, what do you think if this is a triangular prism and this is a rectangular prism, what would this be called? What's the shape at the top called? Not a hexagon. 1, 2, 3, 4, 5. A pentagon, so it's a pentagonal prism. How many faces does it have? 7. 1 at the top, 1 at the bottom, and 5 around the side. How many vertices? 10. And then how many edges? 5 around the top, 5 around the bottom, and 5 around the sides. 15. See any patterns yet? 5, 6, 7, 6, 8, 10, 9, 12, 15. So, this has 1, 2, 3, 4, 5, 6 sides on it. So how many faces does this hexagonal prism have? 8. Vertices? 12. Edges? 18. All right. So for every 1 extra face, you have 2 extra vertices and 3 extra edges. Now, if you just picked out them, what do these two add up to? 11. What do these two add up to? 14. What do these two add up to? 17. What do these two add up to? 20. Compare them to that. F plus V is always 2 more than the E. So we have Euler's formula right here. F plus V equals E plus 2. The number of faces plus the number of vertices equals the number of edges plus 2. Okay, so we're going to apply that to something like this. Okay? All right, Dungeons and Dragons people, whoever plays that, you see dice like this that they roll, and it comes up with one of the sides up. Okay? So it has 20 faces and 30 edges. How many vertices will it have? Well, F plus V equals E plus 2. It has 20 faces. We don't know how many vertices, and it has 30 edges. How do we solve that? We subtract 20. How many vertices will it have? 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 vertices. Okay? A regular hexahedron, also known as a cube, has 6 faces and 8 vertices. How many edges does it have? Well, F plus V equals E plus 2. 6 faces, 8 vertices equals edges plus 2. So 14 equals E plus 2. How many edges is it going to have? 12. So just subtract 2 from each side. A regular icosahedron. A regular icosahedron has 12 faces, or 20 faces, and 12 vertices. How many edges will it have? Well, this is 32. So the number of edges, it'll be 30. Hey, that's what this one was. They're both regular icosahedrons. All right, now we get to the cross sections. A cross section is like cutting something perfectly through. So if we cut this perfectly through like that, what shape will you see when you cut it parallel to the base? How many sides does it have? 5, so it's a pentagon that you see. Now, what if you cut it up and down? What if you cut this up and down? What type of a shape would you see that goes right through the vertex, kind of right down this direction, and then over to this direction, and then back up again? What shape is that? Triangle. So when you cut a pyramid straight down through the vertex, you should see a triangle. Okay, you should see a triangle. All right, here's a regular dodecahedron. A dodecahedron. How many faces will a dodecahedron have, do you think? A dodecagon has 12 sides, so a dodecahedron would have 12 faces. Okay? How could you slice it so you have a triangular cross section? What would you hit? What would you do? Well, you just take and cut off a little corner of it straight down and then make a triangle cross section. Right like that. Okay? How could you make a pentagonal cross section? Where would you cut? I would cut the top off. If you cut the top off, it'll make a pentagon, right? Okay. If you go parallel to the base on this, what shape will you have of this tetrahedron, which is a triangular pyramid? If you go parallel to the base, what shape are you going to see? Triangle. If you go perpendicular to the base here, okay, not parallel. Parallel would make a hexagon. Perpendicular would make what type of a shape? what shape would show up? Well, if you cut through here, straight across to here, and to here, what shape shows up? Rectangle. Hey, we had trapezoid for an answer yesterday. So she's not that far off. Okay, now, rotating a figure. If you take this triangle and rotate it 180 degrees around, what three-dimensional figure would you have? If you took the triangle and rotated it around in a circle, what shows up? A cone. Okay? If you go right through BD. Now, if you go this way through it and sweep this around this direction, what are you going to get? Well, what happens when you sweep it around that direction? Okay, this is point C here. Nope, that's point A here. And when you sweep it around in a circle with C down here and B up here, A sticks out, and as you go around, it'll make two what? Two cones on top of each other. Okay? So, what we're doing today is we're using the formula to figure out F plus V equals E plus 2 to figure out either the number of faces, the number of vertices, or the number of edges. Okay? We're slicing through things to see what the cross section will be, and then we're rotating things. Now, what if I have a rectangle? That I'm going to rotate around this line that's 4 by 6. If I rotate this around, what shape will I make? What shape will I make if I rotate a rectangle straight around something? That'd be a cylinder, right? Okay, makes sense. What's the radius of that cylinder? 4. What's the height of that cylinder? 6. The volume of the cylinder is pi r squared h. We'll learn that as we go along. But if you were told to find the volume of this, it's pi times 4 squared times 6. Or pi times 16 times 6, which is 96 pi. Okay? Can you do something like that? Okay? Rotating figure so you can find it. And then we'll worry about finding volumes. We'll have one problem where you have to find the volume right off the bat. Okay? But then we'll get into more of this rotating and finding volumes as we go through the chapter. So, those of you with makeup work, Charisma, I'd like to start the NWEA soon so you have enough time to get it done. So instead of doing your assignment, I'm going to have you do that. And then